Welcome to this explainer. Let's jump right into a really fascinating paradox today. We are looking at a chemical that is an absolute superhero when it comes to keeping our modern infrastructure safe, specifically by purifying our drinking water. We rely on millions of tons of this stuff globally, making it one of the most vital yet highly hazardous industrial components on Earth. But here's the catch. The exact same chemical, if mishandled, is incredibly dangerous. It can cause severe burns, destroy aluminum, and totally devastate local ecosystems. We're talking about hydrated lime. In this explainer, we're going to unpack how this dual-natured chemical works, and more importantly, how to handle it safely. Here's our roadmap for today's briefing. First, the water treatment powerhouse. Second, stability and storage needs. Third, essential protective gear. Fourth, immediate first aid steps. And fifth, environmental risks and disposal. Let's get to it. Section 1. The Water Treatment Powerhouse, purifying our municipal and industrial water systems. Before we get into the hazards, we really need to understand why this stuff is literally everywhere in municipal and industrial water systems. It's a massive heavy hitter for keeping our environment and drinking water safe. So what exactly is it? Well, hydrated lime, chemically known as calcium hydroxide, is a highly reactive, dry, white crystalline powder. It's made through a process called slaking, where quicklime is treated with water. And here's a wild fact for you. This slaking process is so intensely exothermic that it produces enough heat to actually boil the water it mixes with. The result is a super versatile alkaline powder that is fantastic at neutralizing acidic compounds. Hydrated lime operates on a few different fronts in water treatment, doing three really essential things. First off, it adjusts and neutralizes water pH. Acidic water can eat right through distribution pipes, which leads to contamination, so lime brings that pH up to a nice, stable neutral. Second, it actually softens hard water by stripping out excess calcium and magnesium ions that cause scale buildup. And third, this is the big one, it precipitates toxic heavy metals right out of our water supply. Think of it as a three-step mechanical trap. Step 1, in goes the lime, and the water's pH shoots up. Step 2, this newly alkaline environment forces dangerous dissolved metals, stuff like lead, copper, and zinc, to form insoluble hydroxide compounds. Step 3, since they're no longer dissolved, these heavy metals literally precipitate out of the solution. They clump together, making them super easy to just filter or settle out of our drinking water. Without this elegant little chemical trick, those heavy metals would slip straight through municipal filters and right into your tap. No thank you. Moving on to Section 2, stability and storage needs, controlling the volatile core. Now, that incredible reactivity we just talked about, that is exactly what makes hydrated lime so dangerous if it's not strictly controlled. When it's just sitting in a facility, containment is everything. Ideal storage, you're looking for cool, dry, well-ventilated locations. For bulk storage, masonry or concrete structures are your best bet. On the flip side, look at the hazards. You absolutely have to avoid moisture like the plague. It triggers those dangerous heat-generating reactions. You also want to keep it away from atmospheric carbon dioxide and acids. Oh, and this is absolutely crucial from the source data. Never, ever store it in aluminum containers. The calcium oxide can severely corrode aluminum over time, compromising the whole container and causing a highly dangerous spill. All right, Section 3, essential protective gear, suiting up for safety. So what happens when you actually have to move and handle this material? Well, you're facing serious personal risks, and suiting up correctly is just not optional. The official safety datasheet protocols are crystal clear. Hydrated lime is a severe irritant to the eyes and skin, but the real kicker? It causes severe burns in the presence of moisture. Think about that for a second. The human body is covered in moisture, sweat, tears, saliva. If that airborne lime dust lands on your skin or gets in your eyes, it reacts with your body's natural fluids, basically mimicking that intense slaking process we talked about earlier, causing immediate chemical burns. To stop that from happening, facilities absolutely must enforce strict mandatory protective equipment. You need wide vision goggles with anti-mist properties to completely seal off your eyes. And that anti-mist feature, totally critical. Because if a worker starts sweating and those lenses fog up, they cannot risk lifting the goggles to wipe their eyes. Doing that introduces the chemical dust right to their eye moisture. You also need chemical-resistant fabric or composite gloves, total skin coverage with long-sleeved overalls and boots. And if the atmospheric dust crosses the occupational exposure limit, approved dust respirators or air-streamed helmets are non-negotiable to protect the respiratory tract from getting severely irritated.
Section 4, immediate first aid steps, emergency response protocols.
But look, accidents happen. And with a chemical this reactive, every literal second counts. If your gear fails, the safety guidelines are incredibly rigid. Step 1, if you get lime in your eyes, speed is everything. You have to irrigate the eyes with water for at least 20 minutes, and 20 minutes is a very long time. So that means having dedicated, continuously running eye wash stations, not just splashing water from a break room sink. Untreated, we're talking partial or total loss of sight here. Step 2, for skin contact, wash the area immediately with plenty of water and strip off any contaminated clothing so the chemical stops reacting against your skin. Step 3, in all cases of significant exposure, seek immediate medical attention. Don't wait around.
Which brings us to Section 5, Environmental Risks and Disposal, the ecological paradox.
Now we arrive at our final topic, and this is where the ecological paradox of hydrated lime really hits home. The exact same chemical we use to clean heavy metals out of wastewater will absolutely devastate the natural environment if a raw spill occurs, and it all comes down to the number 12.4. When hydrated lime hits water, the pH skyrockets to an extreme alkaline level of 12.4. For a little context, household bleach sits around a 12. At 12.4, it effectively has a sterilization effect. Great for treating sewage sludge in a controlled plant, absolute nightmare if it washes into a local natural stream. The safety data sheet doesn't sugarcoat it either. It clearly states that because of that massive pH spike, hydrated lime is, quote, expected to produce significant ecotoxicity upon exposure to aquatic organisms and aquatic systems in high concentrations. A large, uncontrolled spill into a waterway will violently spike the pH and immediately threaten marine life. We absolutely have to prevent this material from washing into sewers or open ditches. And because it isn't biodegradable, it doesn't just magically dilute and disappear over time. You can't just toss empty lime bags in the regular trash or wash leftover powder down the drain. Disposal has to be executed strictly at licensed waste facilities, completely in accordance with local and national legislation. It requires a dedicated professional approach to waste management. So we are left with this pretty wild reality. Hydrated lime is entirely essential. We need it to purify the water we drink and stabilize the industrial waste we produce. But it only works if we simultaneously protect our workers and our environment from the lime itself. It demands absolute respect, proper PPE, and strict storage protocols. So ask yourself, is your facility fully prepared for both sides of the hydrated lime paradox? Thanks for joining me for this explainer. Keep learning, stay safe, and I'll see you next time.